Thank you very much, Anna. And yeah, it's an honor to have today Salvador Capella-Gutierrez, who will give us a lecture about ELIXIR web services and workflows. He leads the Spanish National Bioinformatics Institute at the Barcelona Supercomputing Center, which is also the Spanish ELIXIR node. His current work focuses on developing long-term infrastructures to support the scientific benchmarking and technical monitoring of bioinformatics tools, web services, and workflows in the context of ELIXIR. He's also involved and applies these techniques to several bioinformatics projects, such as RD Connect and the Blueprint data portal. He has received his PhD in bioinformatics in 2012 from Pompeu Fabra University in Barcelona on the applications of evolutionary methods to different omics data. He has joined the Barcelona Supercomputing Center in 2017. And before that, he worked in the Spanish National Cancer Research Center. He has participated in different international consortia, which is reflected in his scientific publications covering a wide number of topics. And in particular, he leads the Pillar 3 on use cases, applications, and innovation solutions of the European Genomic Data Infrastructure, GDI. So Salvador, thank you very much for giving this talk today, and the stage is yours.
Thank you very much, Luis, for the really nice words. And I have to say that when I heard your introduction, I realized that it has been many years since I was doing basic research, if you allow me, studying the evolution of organisms and so on, compared to the work that I'm doing today. And I'm happy to share with all of you. So when I was first proposed to talk about ELIXIR, web services, and workflows, I was asking myself, where shall I start? And then I realized that maybe you guys in the audience are not very familiar with ELIXIR, so I think that was a good starting point. So ELIXIR is a pan-European organization. So actually, ELIXIR brings together 24 different countries across Europe, where the objective is to build an infrastructure composed of different pieces, if you allow me, where we connect different experts, where we provide different services, but it's not just services and infrastructure, where we're talking about training, creating capacity, working on standards and different aspects of bioinformatics in general. So if I give a little bit more of a structure, what the ELIXIR does is, as I was saying, about European infrastructure network, 24 countries working together around databases, training, software tools, data standards, compute resources, and scientific and technical experts. I will say that people is essential for the success of ELIXIR. So, and here you have a nice picture of our last meetings in Ireland, where we bring all these people working together across Europe to share the current challenges and to propose new solutions. And when we're saying bringing people together, we're not just thinking in academia, but we're also discussing, for instance, with representative for industry, because many times we say we face similar challenges across different areas and across different countries. So rather than developing our own standards, the plan is to join forces and do it together. So ELIXIR, one of the structure of ELIXIR are the ELIXIR platforms. So ELIXIR have 5 technological platforms. The compute platform builds and integrates cloud, HPC, storage, and access mechanisms to the data that is being available to the life sciences research community. Data look after robust and long-term sustainable data resources. So we can think of Uniprot, for instance, or ENA or EGA and different resources that we see, for instance, provided by EBI and by other places. So we can think also on services provided by our colleague from Heidelberg. String might be an example of a nice and well-developed database for years. Then we have interoperability that look after mechanisms to standardize file formats, metadata, vocabulary. So standardization, we sometimes don't realize how important it is, but without having those standards and those interoperability mechanisms, it's very difficult to connect different databases or to connect different data sources and so on. So interoperability look after that. Training elaborates about national training programs of what is happening across the different ELIXIR national nodes. Remember, we have 24 national nodes, including one ELIXIR node in Germany that is represented by Denby Cloud, and here in Spain is represented by the Spanish National Bioinformatics Institute. So training is looking what are the national training programs, help to bring those together to interoperate, if you allow me the expression, and to identify gaps in those training programs, just to look whether we can provide it as a big network, those, or we can supply those or cover those gaps, or we need to develop specific capacities, because it's important that we manage to bring together many people, that we also need to look how the future will look like, how the professionals that will put forward all these elements are being trained today. Finally, we have tools. Tools, to me, resemble to software, let's say. So basically, what we are looking in the tools platform is about how to find software, how to register, how to benchmark, how to evaluate it, but also how to have a standard and best practices for software development. So we want to have software that is sustainable over time. So, and when you're thinking of software, we might think of a small script that I write today to process a data that I might not need any longer, but we can think also on the software that is running, that is needed to run major infrastructure like GHGA software to provide services for secure data sharing. So as you can see, ELIXIR covers many areas and they are quite technological. That means that we need somehow validation, that to know that what we are doing in the platform makes sense for the broad community. And that is the plan, or that is the expectation from the ELIXIR community. So we here have a number of communities in different areas. So probably you can identify yourself with one of them or more than one. But the plan here is how we connect the different platforms, so the technologies that are being explored, the technologies that are being developed across the different platforms with the communities. Because at the end of the day, what we want to have is something that is fit for purpose, that is useful for researchers, that is useful for the whole community. You don't want to propose a best practice for software development that no one is using, because then means that first, you didn't understand the challenge, you didn't understand the problem. Second, you have invested a lot of time in an area that maybe is not very attractive. So the idea is how to make that handshake and move forward, because we have many challenges ahead. So if I go a little bit deep into the tools platform, that is the one that I know better. So we have different areas. So we are thinking of packaging, containerizing, and deployment of software. And that is very important when we want to have reproducibility in research, when we want to have software quality. And if we want to have workflows, especially, and coming back to the title of today, we want to make those workflows being executable, not just in a specific machine, not in my laptop, but maybe I want to have it in a cloud today, and maybe in an HPC center tomorrow, and maybe the day after I want to share that workflow with my colleagues in another institution. So how do I do that? Probably the having software containerized is going to help. Of course, we want to do benchmarking and technical monitoring, meaning I want to understand what is the performance of my particular software, of my particular database, of my particular workflow compared to others. If I'm choosing one, I can be I can ensure that the decision is an informed one, meaning I might not need necessarily choose the best one, but I know what I'm choosing. What I'm saying, I'm not choosing the best one, because maybe the best performing tool needs a HPC computer and HPC installation, right? While the second best one or the third best one might need just a laptop. So there are different elements that might influence on the final decision on which software to use, but at least I'm taking an informed decision. Then, of course, registry of bioinformatics tools and tools information identifiers, I will say even that is probably the first one, because you want to make sure that you are able to find software relevant to your question, to your research. So when I was doing basic research during my PhD, I always was confronted with a research question, right? So how these particular organisms evolve, or how do you compare these organisms with others? So then I have the question of, do I have the right data to answer that question, yes or not? If the answer was yes, then I ask myself, do I have the right software to process that data to answer that question, yes or not? My time say, well, if there is none, I'm going to program it because I have a strong technical background. But today, probably what I will do is just to go to registry of bioinformatics tools and look what our options are. And if I don't find anything, or I find something that doesn't convince me, then I will go and then develop my own software. Finally, software best practices. We need to develop software that is being used for today, tomorrow, and in a month, and maybe in a couple of years. And that implies that if I start adopting these best practices, from day one, it's going to be much easier. What it means, so for instance, if I'm writing code, having a repository, GitHub, GitLab, or any other alternative, and documenting my software as I will create it in few months in time. So those practices might take few minutes of your time, but they are going to pay off. So meaning, if I start documenting my software today, in 2 months or in a week, in 6 months, when I'm submitting my paper, for instance, or when I'm sharing that software with someone else, I don't have I will not have the trouble to say, oh, now that I have finished, I need to go back and document. The documentation at that point is not going to be as precise, as good as doing it today. Because if I'm documenting little by little my code as I develop the code, it's going to be more precise and it's going to take much less time and energy than if I have to do it afterwards. The same with contribution policies, so who is allowed to contribute my software. If I have it in a repository, who can contribute to that? It's a closed repository, it's an open repository. How do I recognize contribution of others? So all of these aspects, these 4 items on the left, are being taken, are in the radar, if you allow me the expression, of the ELIXIR platform, but resemble and are very much connected with this idea of reproducibility in research, software quality, standards, and software management plan, of course, a comprehensive catalog of tools. So those are elements that map one to another. So if I, well, here you have a little bit what is the mapping, but if I go a little bit ahead and then I start thinking in specific products on this process of finding, evaluating, deploying, and running software, and especially running workflows, I will start identifying products, platforms, and registries that are in the scope of the ELIXIR Tools platform, right? So if we think on registering software, on finding software and workflows, then we have Biodoc tools and Workflow Hub. So Workflow Hub is a really nice registry where you can publish the workflow that you have produced, and then you have a number of elements that help to disseminate, to visualize, or to visualize, right, the work that you have done. So for instance, you have a DOI. So with that DOI, with that digital object identifier, then you can include it in your publications, and then you have a direct link to your software. In Open Events, we have a platform to benchmark software, but also to monitor technically monitor software. When I'm saying benchmark software means as a community effort, not as individual software. And later on, I will go a little bit in that direction. For the deployment, we have Bioconda. Probably many of you are using it. Bioconda and Evolution, I will say. And then Biocontainers, that is again is a registry of software containers. And finally, we have Galaxy as a workflow manager ecosystem. There are many others. And in the tools platform, we have been mostly working with Galaxy, then a little bit with NetFlow and with the SnakeMake that also sounds familiar to you. And as I was saying in the slide before, but also raising awareness about software best practices. When I was a PC student back in the days, I didn't pay much attention to this part. But with the time, you realize how important it is to have good practices or best practices for developing software. Especially because when you publish a software, and if you want contribution by the people and so on, it's much easier if the software is well documented. So if we go a little bit down in the tools platform, what we have created is this idea of research software ecosystem, where we have this triangle where we are bringing together the curator's perspectives of people who look at the software, how it has been generated, how it has been registered, and so on, of the workflows, for instance, and try to keep the information updated. We have the user perspectives, so you, for instance, where do I find my software, where do I find my workflow, how I can run this workflow in Galaxy, how do I benchmark that particular area. So then we have this aspect here. And then we have the developer perspective that some of you as well can have that role. The how do I contribute to the whole ecosystem? How can I learn from the different practices in ELIXIR? So the ecosystem is how to bring those perspectives and those needs together and make sure that, for instance, when you're describing the software, and by software meaning individual tools or workflows, that information is captured and is distributed across different platforms. Meaning, if I register a tool in bio.tool, how that information can be exposed to Open Events or to Galaxy or to Conda or Bioconda. And similarly, where can I find information that is consistent across different platforms? And that is an effort that has been doing over the last few years, and we are going to continue doing because there are many opportunities. And at the end of the day, it's lowering the barrier to have better quality data, metadata describing software. So now I'm just jumping specifically in benchmarking. Benchmarking and connected to this idea, the workflows, what services, individual tools, and so on. I will say that benchmarking, everyone have an idea that what benchmarking is. We're doing benchmarking every single day in our lives. Since when I'm buying a phone or a car, when I compare, so benchmarking at the end of the day is just comparing different same or similar products, similar software, to take an informed decision, right? And we can use many indicators. So in science, we do the same. But here, probably the difference is that we are taking a community-driven approach. Why we're taking a community-driven approach? Because we want to have a more complete and unbiased benchmarking, and the unbiased component is important. Usually when you publish a bioinformatics tool, what you do is, well, I find the data set that best represent my interest. I find the best metrics that capture the performance of my tool, and then I prove that I'm better than the rest, go to a scientific journal and say, look, this is my contribution to the field. And that is fine. There's no criticism to that. But here what we want to have is a more holistic way. So we want to understand what are the challenges, all of them, because then we can find different software being good for each of the different challenges that the whole community is facing. So we want to find that way to combine, identify challenges and to combine efforts and so on. So that is the reason because we're putting the focus on community-driven benchmarking rather than individual benchmarking efforts. Of course, it is not only useful for software developers, but also for users. If I have to take an informed decision, probably I'm going to go to that forum that brings together different tools and offer me an overall picture, right? So in that context, we developed many years ago Open Events, where we're evaluating individual tools, web services, workflows, and so on and so forth, not just scientifically, but also technically. So for instance, if you go to Open Events nowadays, you will see an interface similar to this one, where we have different components, right? So where we have benchmarking, what we call benchmarking has to do with the scientific benchmarking of software. Then we have the tools and metrics where we're looking individual entries of software. And then when you have the tools observatory, where we are just putting together all the information that we're learning about the specific tools and see what are the general trends. And then you will see what is the value of making such an effort. So individual tools, and by the way, we are renovating this area in Open Events, so you might see changes in the coming weeks because we're exploring and then looking forward to how to revamp and offer a more informative or a nicer experience. Since the first time that we published these tool entries a few years ago, here you have the information about a particular tool, publication, response times, the availability of documentation and others. We're also incorporating the FAIR for research software metrics in this individual evaluation. You see how fair a given software entry is, and to compute that fairness, what we look is how easy it is to find the software, what is the metadata to facilitate finding the software, what are the interoperability aspects, the documentation. That means that is very much linked with the R, with the reusability and so on and so forth. So we are providing a detailed evaluation of individual tools. So then if we go to the software observatory, then we are bringing that information together, not just from open events, but we are combining information from many different places. So here you have a screenshot of all our data sources, and then the combination of all this information to the right general trends. General trends mean that half of the people use licenses, and that is worrying, because meaning that half of the software shouldn't be used, because if you don't have a license, you shouldn't be using that software. Sometimes in research we don't care much, but to be totally honest, we should be strict with that. Why? Because if tomorrow the owner of that software comes and say, well, my license said that you didn't read it, but my license said that you have to pay me €1,000 license to use my software, then you might be in trouble, especially when we're working in the research arena, right? So my recommendation will be, don't use software that has a license, and if that software is very relevant to you, try to contact the author to understand what are the license, and eventually ask them to make it public available. Then you understand what are the terms of the way to use that software. And then when we look at that other half of the licenses, the software, most of it is open source, which is good for the community, but understanding that is important. And you will see that we have open source and then we have unambiguous. Why? Because sometimes we have found that software is being registered in different registries in different places, and then the licenses are not matching perfectly. Sometimes you say GPL2 in one place, and maybe 1 year later you register the software and then you say GPL3. Basically, the licensing goes in the same direction, but they are not the same. So then we have this ambiguity, which one is the version of the license that we should assign to software. That is something important to bear in mind. That is the reason, because at the very beginning I was talking about this need to consolidate the data describing software, this need of bringing together different resources. So you do the registration, for instance, once, and then later on you just propagate that information. So another thing that we learn is, another thing that we learn here is that half of the software have a repository. So half of it doesn't have a repository. And this is important, I guess, for your mental health, I will even argue, because having no repository means that all the changes that you are introducing to your software are not tracked, and they might be lost. So I still remember the day that I forgot to commit some changes to my software after 2 or 3 days. My computer, something happened, was gone, and then the work of those 2 or 3 days were, disappeared, and it was under a very time deadline. So then I have to spend the whole following nights just rewriting the code for that particular project. That was stressful. And that day I learned that it's better to use software repository, where you are systematically committing all the changes that you're introducing the software, where you can track bugs, where you can document, where you can interact with the community. So if I go further in the scientific benchmarking in open events, here, as I was saying before, we're putting the focus on the community effort. So we're looking at the data sets that help me to evaluate or to represent the challenges, and then to evaluate how good the software is doing. We're putting the focus also in evaluation metrics, which one are the most representative ones, and then the results interpretation. Because sometimes one for a community is the perfect mark, but for another is the worst. So we need really the experts to tell us how to interpret those results. So here you have a glimpse of the different communities that we are working with. We aim to work with as many as possible, but it takes time because we need to understand the different communities, and each of them have a different area. They focus on different aspects. And then we have recently established what we call project spaces, so just to accommodate those communities, those projects that are working with us, to give a sort of a Wikipedia where they can introduce the project, or the explanation of the metrics and so on. So then you start creating and you start incentivizing or you are creating will be the right word, the community around that particular area. So here you have a screenshot of how open events look like. There is the evaluation for a particular challenge. In open events, where you have the different participants, right? So we have here 20 plus participants, and how we cluster them, meaning the best tools goes to the bottom right. So whatever is closer here is the best one. Of course, it's very difficult to decide whether this one is this one or this one are the best one. So they are just in the frontier, in the Pareto frontier. So what we do in Open Event is just we provide a way to group tools in different quartiles. Usually we use 4 quartiles, so meaning that any tool that is in the first quartile are going to offer you a good performance. Not necessarily a particular tool, but it's just one of those groups is going to do well in this particular area, because maybe a tool here that is doing quite well in another challenge, meaning other data types, other biological domain, might doing terribly bad. So it's always a question of how do we interpret things. And here is an example. So here in Open Events, we offer kind of a summary of a number of tools across different type of challenges that imply different data sets, different metrics. And then you see that there are tools that are doing quite well in one particular area, but they are not doing that well in others. So by having this table, as a user, I will come here and say, okay, so if I want to work with, let's say, with eukaryotes, so probably I'm going to look at a tool that is doing quite well here, right? So I will find this OMA get orthologs, they want to work for me. If I'm working for something else, a functional test, like the Go terms, for instance, probably will change my selection and work with another one, with Ensemble Compara, the data provided by Ensemble, right? So that might be my choice. But I have all this information all together and then summarized to me, so then I can take informed decisions. And how do I generate this table? Basically putting together these tables that we saw before by challenge in a single place. So if you ask me how do we engage with in open events, so we have 3 levels of engagement. Level 1 is the easiest. It's the way we visualize data that has been generated somewhere else. Level 2 is where we do the tools assessment. So basically you generate the predictions somewhere else, you submit the predictions to us, and then what we do is that we measure that. So we keep the gold standard, the reference data, we measure the performance, and then provide it to the user. If the user, the developer is happy, then we publicly provide that information. So we don't do anything without the consent of the participant. And finally, level 3 is when, rather than submitting your own predictions, what you do is just submit the software. You submit the software containerized, you submit the workflow containerized, and then we make the evaluation. The good thing about level 3 is that you can not only measure the scientific performance of the tools, but also the technical performance in the sense of how much time, how much memory, how many CPUs, and this kind of elements. The question here is just to make it in a installation that is the same. So because we don't want to compare the performance of a tool in a single core processor against something that is being using a whole Mare Nostrum. Mare Nostrum is our HPC system, and then make the comparison. So we need to set up the right framework to make the comparison right. So then here is a little bit talking about workflows, how we structure everything. So we have at the heart of the open event, we have workflows that allow us to make that evaluation. So, and those workflows have 3 conceptual steps. Validation, meaning we check that the format is correct, that the IDs are correct, that everything is correct. We don't want to give a bad score because the input data wasn't in the right format. Then we have the metrics generation, where we really measure your predictions against what we know, the reference data, and see how well or how badly you are doing. And then the consolidation, where we combine the results of individual tools with the rest of the tools. So this nice visualization that we see before, and then we register that. Good thing about those workflows is that first, they are public available. Second, they try to represent all the steps and all the transformation of the data. So then we're very much thinking in provenant, we're thinking very much on fair data by design and many of those elements that we're talking about in the general context of ELIXIR. Of course, if we go further, level 3, rather than just getting your predictions, we just ask data that is being containerized, so workflows that we execute that are going to generate this output that we later on evaluate. So there is like one level depends on another. The visualization depends on the benchmarking workflows, and the benchmarking workflows depend on the data that been generated by level 3 by the different participants, the different tools, and so on. So if we go a little bit further, the way to use open level 2, for instance, is using our own virtual research environment, where you will find the tool just ready for you to be utilized. And then if you want to go to, here is a little bit of the workflow that I was explaining before. So if we want to go to level 3, what we need actually is like those workflows, those software being packed, being prepared, and ideally using an auto crates or research objects crates that used to describe those workflows. Then the workflow be made available to open events, ideally through workflow hub, so that we can automatically fetch that information. Then we will run it for you and then expose the results to you as a developer. And once you are happy about that, then the whole community can access it. Why this system? Because when someone is looking at the workflows and say, I like this one, how do I use it? Then all the work has been done. All the workflow has been containerized, has been described, it's made available. So then I can even go to Workflow Hub, click, and deploy that workflow in Galaxy. If the workflow is in Galaxy, of course. If it's in SnakeMate, don't expect the workflow to be deployed in Galaxy, right? But the whole thing is, by doing that effort, I can benefit all the work that has been done by the community. So remember, we are here not to reinvent the wheel. So we want to use standards and so on and so forth, because we might end up reinventing the wheel systematically and end up nowhere with 1 million standards that are just being used by myself or by the people developing them. That is one of the key aspects in ELIXIR, how we work together to avoid having developing a number of times the same solutions. So here, for instance, is AutoCrate. So it's not developed by us, it's developed by people in ELIXIR. So just to finalize, if you want to know more about open events, if you want to know more about benchmarking workflows and those elements, I invite you to have a look at open events, and then of course to get in contact with us. So what is next? So of course, keep contributing to the ELIXIR research software ecosystem, automatize currently manual processes for accelerating data access and distribution. So many of the aspects here we first do it manually when we're happy and we understand that they serve to the community, then we automatize them. We want to incorporate new data visualization mechanisms. If you come to open event and say, guys, you can do better, or you can represent this data better in this particular way, we're happy to hear about that. Of course, we want to update our data model. We have been trying to do that for the last couple of years, but it's always something happens. So we're in version 1.99.99. So hopefully before the end of the year, we will manage to make the jump, because sometimes you feel that you are not ready, but we are almost there. And then, of course, we are very much looking forward to reviewing all the time our documentation and complementary materials that we have to facilitate research data management in the whole ecosystem. So we are also working with creating a playground, so then you can come to open events and then play with the different data set that we have and to understand better the system. So we are also contributing very much with the eVerse. eVerse is a coming up software or software quality oriented project where we are going to be looking at the software quality, and then that is something that is close to my heart, and I think it's important to develop conceptual interoperability. So when you go to different platforms in benchmarking, we can think of OmniBench, we can think of grand challenges, we can think of dream challenges, we can think of open events, that we use the same concept. Because sometimes what we call participants, people call it tools, what we call input data, they call it reference data, and then sometimes it's confusing for people. So it's important that us as a benchmarking platform use the same terminology. With that, I would like to thank many people in this area, in the tools platform, where we talk a lot about workflows, software in general, and then the team in open events, and of course, thank you for staying around and participating in the talk. Thank you.